Okay, so for today, we're going to be talking about logarithmic functions. And logarithmic functions are very related to exponential functions. They're actually the inverses of them. And so I think it's good for us to talk about exponential functions real quickly. Remember when we wrote some functions, say, okay, how much money would you have if you, let me get a pen, wrote, invested $500 at 3% interest for 20 years. And normally you'd put a 20 here, right? And that would be if you got paid 3% every year for 20 years. However, it says 3% each day. And so that's when we say, okay, well, it's for 20 years, but every day for 20 years. And so that'd be 365. So that number is going to be quite outstanding. And it's going to be 2.57, I believe, times 10 to the 96 power. So it's quite enormous. The next one's going to be if you get paid 3% annually, and that would be the amount of money you would have would be 500, and then 1.03 to the, it'd be 20. Okay, and that would be 903.06. Okay, that would be how many dollars you get. 3% quarterly, remember you do 500, 1 plus 0.03 over 4 to the 4 times 20. And that would be, I don't have my glasses on yet. So 907, I believe is what it says, 0.02. So it's a little bit more. If you do the math and you see that third number is a little different, it's because I can't, my contact's quite in yet. The next one is compounded weekly. And so that would be 500. And then it would be, not equals, parenthesis, 1 plus 0.03 over weekly, there's 52 weeks in a year, to the 52 times 20. And that would be like $910. Okay, and so now remember, if it's continuously, then it would be 500, and then it would be e to the 0.03t, okay, which would be 20 in this case. So that would be the most you would get, except for the one if they pay you 3% every day. That's the exception. But if it's just 3% a year, and then they change how many times they pay it, that would be the PERT. Okay. We also are going to be practicing with exponents because I think it's important to be able to say, do you know how the exponents impact a base? And so this would be 1 over 64. Because not only does it cube it, but it flips it over. This right here takes the 4th root of it, which would be 2. And then this would be a 1 over, and then it's going to be a 1 without many zeros. And so you could write it as 1, 1, 2, 3, 4, 5. If that's, I believe that's a 5, so we're going to do a 1 with a 1, 2, 3, 4, 5 zeros. Or if you divide it, you're going to get a decimal as well. And so the decimal equivalent would move the decimal over as well. And then the last one's going to be, if you bring this to -2, it flips over and squares it. So it'd be 9 over 4. Okay, so today's lesson is going to be talking about, if you have an exponential function like 2 to the x for this question right here equals 512, how would you solve for x? Okay, we have one way to make the bases the same and set the exponents equal, but you can't always do that. And so the question is, what do you do? Okay, that would be in the one below it. What would you do, if you can't make the bases the same? And logarithms are going to help us reach what we need to. So we're going to talk about this. And one of the reasons why we learned, they came up with logarithms was because it helped be more efficient with multiplication and division. And if you think about, before they had calculators, back when they were building the atomic bomb, etc., Einstein, they had something called a slide rule. And a slide rule helped people convert numbers that they wanted to multiply or divide into exponential form. Because if you remember, it is really hard to multiply decimals, isn't it? Or it's even harder to divide decimals. And so what they would do is convert the two numbers, I believe, into exponential form. Because when you have an exponent, what do you do when you're multiplying with an exponent? Well, you add those exponents. And so if you would add those in exponential form and then convert them back to what they really are, that'd be easier. Also for logarithms, if you convert things that you want to divide into logarithmic form, divide them and then get them back into regular form, because division is subtraction in an exponential form, and then get them back to what they normally are. That would be really helpful. Okay. And so I'm oversimplifying what it is. But many people in college, like grandparents of yours, probably learned how to use a slide rule, because doing the calculations by hand would have been incredibly tedious. And so that was definitely a tool that people used. But since we've got the invention of the calculator, people don't use it as much. But the invention of logarithms are absolutely helpful, because they help us solve when the x is in the exponent. So we learn logarithms, even though there's not that, that basic application that we use on the daily. Okay, like your grandparents probably did. So I think the big thing for me is, let's learn how to convert it from exponential into logarithmic form, and then say, how will we use it? Even if we have calculators, how will we use this as well? Okay, so here we go. So in an exponential form, this is exponential, and this is logarithmic. Okay, I put a G at the end, so logarithmic form. Okay, so to convert it, you'll notice the base is going to be the thing that holds up the exponent. The base down here is the base as well, okay? And then the exponent, it goes on the right side, and then the answer goes as the argument on the left here. So it's going to be left, right, center, okay? So you do the base to this power here equals that argument right there. And so we'll practice converting things. We'll practice thinking about it. But I think, yes, you've got to kind of think about, like, okay, where does the base go? Okay, so when you write something in logarithmic form, and I'm going to write out here so I can see it better. We're going to write log base 3, okay, to the 5th goes over here, left, right, and then center is 243. So the problem, how you'd read it would be log base 3 of 243 is 5. That means 3 to the 5th power gives you 243. That's how you write an exponential thing into logarithmic form. So these guys would be the same. Log of 25, base 25, yes, that's the base of that exponent, to the 1/2 goes on the right, equals, okay, the answer is going to be 5. And so, practicing writing 10 to the 4th log, sorry. The 10 should be little and short, okay? And so I should erase this because it does definitely look terrible. Okay, and some of the fonts are not the best over there on the left, so I'm sorry. Log base 10 of 10,000 is 4. And that's how you'd read it, okay? Log base 6 of 1/6, okay? Log base 6 of 1/6 is negative, and that means 6 to the negative 1 is negative, is 1/6, which is true. And then log of A to the B equals C. So log base A of C is B. And so the answer to a logarithm is going to be an exponent. Okay, and then converting this over here to say, okay, how do I, go back, because I think if you're learning a language like Spanish or something, you're like, oh, I hear something in Spanish. What does that mean in English? Okay, and so if it's in exponential form or logarithmic form, can you write it back into the exponential form? And I think while we're here, let's talk. We have some rules about logarithms, okay? Some of the rules are going to be, hey, this base is not going to be 1. Why? Imagine if you made the base 1, okay? 1 to what power gives you 5? Well, nothing. It's not possible. So really, truly, we don't make this thing to be 1, because 1 to anything is always 1, so it would always be log base 1 of 1, okay? So you may see that occasionally, but we don't on the regular make the base 1 because it's pretty boring. The only thing you can put as the argument that would ever work would be 1, okay? And so the other thing is we also keep the base positive. We don't normally see like a -2 here, Okay, -2 to the something. Why? Can't really do it. -2 to stuff is not going to become a positive number. So we say, let's keep the base positive. Let's make it not be 1. And we don't even make it 0. Okay, so those are some things that we do keep true for logarithms. There's a couple more things too, but we'll learn them as the days go on. This is layers. To start off, that's enough. Okay, so to get it into logarithmic form, we want to start with that base. Okay. I always say, if you have a little brother or sister, you know, they always get to go first on whatever they do. Okay. So you start with that little base. So you go this base. Okay. To the power on the right is going to give you the argument. So you would go 9, that little base right here, to the first gives you that argument, which is right here. Left, right, center. And so you'd go 2 to the 9th equals 512. 8 to the 1/3 is equal to 2. 4 to the -2. So start with a little base, raise it to this power on the right. Okay, the answer to logarithm is going to be the exponent is equal to 1/16. And then 1 to the 0 equals 1. Now notice they did use a 1, didn't they? You know, and it's B, sorry. B to the 0 is 1. Okay. And that's true. I want you in your head is that stop to the 0 does give you 1 as an answer. Our kitty cat is coming to see what I'm doing. All right, so evaluate. Okay, now the next thing is we're going to practice saying, okay, if I give you a logarithmic question, what do you get? You know, what do you get for an answer? Okay, and I think this is good practice to say, you know, starting with a space, raising it to some power. Well, how do you get the target answer of 81? Okay, and so the answer to this one is going to be 4. Okay. Because 3 to what power gives you 81? And you have to kind of try it on and be like, okay, 3 to the second, no. 3 to the third, no, that's 27. Okay, 3 to the 4, oh, that's right. Okay. Same with this one, 1/2 to what power? X equals 256. You're like, I don't know. Well, you know, a half is a fraction. We have to not make a fraction, so we have to make it negative. And then you can try it on and be like, okay, well, it's going to be -8. Why? The negative flips it over, the 8 raises it to 256. Okay, and then 16 to what power gives you 4? You're like, I don't know what to say. Well, okay, to make something smaller, you could take a root of it, okay? And so that's going to be your answer. Okay, 16 to the 1/2 or square rooting of 16 is going to give you 4. And so to think, what kind of things can exponents do? They're kind of magic. Okay, they can take things to powers. They can do reciprocals by making them negative, and they can take the roots, you know, by making them fractions. And so that's kind of in your wheelhouse of like, I can do these things using a fraction. And so this is going to be a half. The next one says 5 to the what is 125. Okay, that's easy. That's going to be 3. And then this one, 5 to the what gives you 1/5. Well, -1. Okay, think about what is in your power. Okay, the next couple, 2 to what power is 3? But 2 to the third power is what? Okay, so remember the answer to raising the base to a power, the powers on the right, gives you this answer. So 2 to the third gives you what? That's 8. Okay, the next one is going to be x to the second gives you 36. Okay, what could that be? Well, that could be 6. Could it be -6? Well, the answer is no, because remember the base is always positive. And so, although x squared is 36, could be plus or minus 6, the base cannot be negative. So that's not an option. Okay. This is 5 to the third is equal to x. So that's 125. So knowing how to read it, knowing how to say, okay, what are we doing? 5 to what power gives you 1? That's 0. 5 to the x is equal to 125th. Well, it appears that we need an exponent who will flip over the fraction and the number and also square it. So it would be -2. So think about what are your options for powers, okay? And then on number 6, we've got 5 to what power is 1? That would be 0. 2 to the -4 is going to be x. Okay, so you do 2 to the -4. Okay, that means bring it to the 4th power and flip it over. That would be 1/32. Actually, I'm lying. It's going to be 16. I was getting a little happy. I raised it to the 5th power, not the 4th. Okay, and then this one, 5 to what power gives you? Okay, that'd be -3. You may want to pause the video and try some of these. X to the third is 8. -3 is 8. Okay, so you have to say, if I raise x to the -3 and I get 8 as an answer, what would x have had to be? You're like, well, the -3 flips over, so I've got to start with a fraction, so I end up with a nice thing. And then answer is going to be a half. Okay, if you take a half to the negative 3, you flip it over and then cube it, that will give you 8. Okay, x to the 1/2 is 15. A lot of people struggle with this. They're like, I don't know what to, okay, what does square rooting do? If you, I mean, 1/2 square roots, I told you. So if you square root a number and you get 15, well, what did you start with? We start with 225. Now read at the bottom. If I don't give you a base, we're talking about base 10. Why? Because we live in a base 10 world. If I talk about 235, it's not 235. It is 200s. 2 times 100, 3 times 10, and 5 times 10 to the 0. So every place value represents a factor of 10, okay? And so we're talking about factoring times a 10 to the power. And so, yeah, we live in a base 10 world. So it's implied that if we're talking about logarithms without a base, the base is 10. Okay, so 10 to what power is 100? Well, that's 2. 10 to the 0 is going to be 1. And then 8 to the 2/3. Ooh, do you remember how to do fractions? Remember, the fractional exponents, raise it to the power of the numerator, and the denominator is the root you take. So you can do it either order. So if you cube root 8 and then square it, you're going to get 4. Okay. And then next one, x to the negative 3rd is negative 8. It's going to be a half. I think you already did that question. And then this one, 10 to what power is 1/10? It's negative 2. Okay. So, oh, I lied. Let's make that negative 1. Okay. And so that's our lesson for day 1. All right. Thank you. Have a good day.